Developers build the future. We take ideas and make them real. My job is to think, create, and solve for a living.
Each step we take is possible because someone asked questions. Why do we have to do it this way? What if we did it that way?
Each step I take enables people to go further.
Be creative, change something. I'm working on blockchain that will change asset identity.
Artificial intelligence to automate homes.
Autonomous robots to improve efficiency.
My app is advancing human rights.
I build things to help connect people. Not everyone gets to build their passion. We share what we know. We share what we do.
You try, learn, try again.
Make, break, build.
Ladies and gentlemen, please welcome George Saab.
All right, wonderful. It's great to be back here in San Francisco. Great to see you again. We're here now for the Java keynote in the inaugural Oracle Code One conference. And I'm going to let you guys in on a little secret. There's a gentleman who did a previous keynote earlier today who's still backstage. And I think he could really use hearing from you what you think about Java. So here's what I want to do. He has no idea we're doing this. If we're loud enough, he's going to hear it. All right, so what I want to do is just Java, 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 Java. Come on, that's better. Come on, more, more. Oh, yes, all right. Awesome, OK. He's probably shaking in his boots back there. All right, this is good. OK. Everyone, I'm glad to be back. As you know, we have a new name and a new look for the conference. But as always, we have great content. There are lots of great speakers and the opportunities to learn so much about so many technologies. And of course, you continue to get unique access to the team and the folks who make Java and listen to their talks. OK, so one tradition that we've always had is an award, and this we're going to be keeping. This is going tomorrow at the exhibition hall, and it's called the Duke's Choice Award. This is actually a huge honor for those who get it. It's a way for us to actually recognize some of the best people and some of the best projects in the Java ecosystem. So please check that out tomorrow. OK, and we have another great tradition, which is partying and listening to excellent music together. Whether your favorite thing is going to listen to the Null Pointers play, shout out, yeah. Or whether you want to see some of the top musicians in the industry, like Beck, tomorrow night at AT&T Park. It's just down the road where the San Francisco Giants baseball team play. We have a few Giants fans here. All right. Sorry, not tomorrow, Wednesday. So definitely check that out. OK, finally, I want to thank all of the great sponsors that we have for Code One. It truly is a group effort to put a large conference like this together. We appreciate all that they do, and I hope that you will help us support them and recognize all they're doing to help bring this conference to you. And now it's my pleasure to bring you one of these sponsors who will be giving a vendor keynote. I'm really, really pleased to welcome Matthew McCullough from GitHub.
Hi, Java friends. Thanks for giving me the privilege of talking with you today. I have a little bit of a story to tell, but first, our intros. I'm Matthew McCullough, and I'm delighted to be here with my GitHub colleague, Rafer Hazen, and two of my Oracle friends, Joe Darcy and Eric Duverblad. You may be wondering why I'm so excited this late in the day. And it's because I get to talk to you about GitHub and Java. That's like offering me espresso-flavored chocolate. My vice is admitted. But Java has long been an important part of my career. And while my development journey began with 6502 assembly on an Apple IIc, I see the hand back there and the shout out for that, in the mid-'80s, Java was my first programming language that felt expressive and welcoming to me. From buying a copy of Core Java at the Denver Tattered Cover in '96 to being gifted a copy of Java in a Nutshell in '97. We can get another round of applause for that, too. Yes! These past 22 years have just flown by. And in those 2 decades, we've seen the internet become the backbone of collaboration. That's enabled entirely new means of advancing software projects to become possible. Open source, Git, GitHub, just to name a few. And today, that combination of technologies takes us to the future of OpenJDK and Project Skara. Very excited about this. I want to emphasize that this is an investigation. And yet, Project Skara has aims that closely align with GitHub's own mission of helping devs all over the world build better software together. I'd like to share some of what we found along our 10-year Git and community journey, just as OpenJDK embarks upon the next stage of its own. So today's showcase is comprised of several parts that make a more potent whole. In fact, 4. So let's begin. While as technologists, we frequently talk about our engineering choices and technical wins, software projects of significant scale are built by a community. And I'm going to share some relevant GitHub data and together explore what you can do to grow and strengthen your own project's community. So let's talk about what we found to be a magic number. With all the industry talk about big data, this may shock you. 1. Not 42, but 1. We're often asked to focus on big results and the types of changes that an annual release might bring to your application or software. But I'm going to ask you to focus on this much smaller number, some fixes to code, making it a little bit speedier, adding some automation, solving a paper cut, adding some knowledge, and growing the community. 1 is the power of you. And if you take that answer and apply it to the last item in the list, well, then it becomes the power of us, community. So, why is that? Because when those simple goals of 1 become canon and are undertaken by an entire group, like you, the result is a healthy software project ready to attract new users and many more contributors. Even as Rafer and I discussed this very presentation with our Oracle counterparts, Joe and Eric, they affirmed this statement. These days, very little software of consequence is developed in isolation, but rather in a mode of global collaboration. Just look at the audience represented here today to know that that's true. If you also believe this, then our shared goal for tomorrow should be making global collaboration easier. And so, my first request of you in this action-oriented presentation is to think small to accomplish more. And a flashback to those tasks. 1 bug fixed, making the software 1% faster, automating a single task, adding a modest feature, answering a single question, and growing the project by 1 new contributor. I was able to spend a few minutes with Chad Aramura, Vice President of Serverless at Oracle, last week. And he reiterated what the power of open sourcing even 1 project can do to attract more talent, more eyes, and more hands to a software endeavor. Let's hear it from him directly.
We found an opportunity to announce the open source of FN project at JavaOne last year. In fact, we had sponsorship all the way up to the top. There was probably 5,000 people in the audience, 50,000 people through the live stream. And we added a little bit of theatrics to it where on stage, I pressed the danger zone, like you're in the danger zone, and I pressed the GitHub make it open source. And it had a really big impact. And from that moment on, almost weekly, I have engineers from inside of Oracle reaching out to me and saying, how can we get involved? How can we participate in the project? And that's something that it really helped put us on the map by doing something like that. And it was an opportunity to help kind of spread awareness.
And that community, nowadays, is a blend of developers that work in enterprises, are end users, hack on projects as open source enthusiasts, and you'll see that in the mix of users on GitHub. A significant number of them identify as members of all of those personas at times: enterprise developer, end user, OSS contributor. And speaking of existing communities, as GitHub's own developer advocacy efforts continue, our community continues to grow. And my thanks to all of you in the audience today for your commits. You're part of that 31 million users that are now on GitHub, and you've made over 1.1 billion contributions in just the 10 months so far in 2018, an almost unfathomable number just a few years ago. And Project Skara has already dipped its toe into easier code navigation with its read-only mirror on GitHub. Millions of developers are already viewing the source, thousands right now, millions soon in the future. I always have this aspiration that help is on the way and more numbers are soon to come. That we've got a few automation enhancements that I think will bring us those millions. We've got some things up our sleeve that Joe and Eric are going to show us soon that will serve OpenJDK's community needs. But even with all these gigantic community numbers that we just discussed, I do want you to stay focused on just one. All it takes is a little bit from each of us collectively to make a tremendous difference in a project like this. The GitHub product, sales, training, and engineering teams, Rafer representing that, spend a lot of time thinking about the power of one, the power of each and every one of our users, developers. And our annual research project drives us to do so with even greater depth. We call the study's results the State of the Octaverse. We just released it last week. And it's our summary of what's happening with software developers the world over. We have to keep that global view because over 80% of our contributions come from outside the United States. And that's also represented in the faces and countries represented at Code One here today. And while you can read the report in its entirety outside of this presentation, I wanted to pull out two relevant points. The first is that Java has a silver medal presence in the site, and has for a number of years. That straight line across. However, knowing the competitive nature of Java developers that I've had the privilege of working with in the past, I see this as a goal. And when I've said I've always enjoyed the Java community, now I can quantify that with your emoji reactions to issue and pull request comments. Java dominates the +1s, shies away from the downvotes, and still needs to learn how to party. So I suggest you work on that particular fact.
About emerging messaging systems. And I want to tell you a story about how they grew into a much larger pattern. So I'll start at the beginning. GitHub, as you probably knew, started as a fairly conventional Rails app. But we quickly found ourselves needing to process background jobs, basically to offload things that were too slow or computationally expensive to handle during a request. So that led to the development of Rescue. Rescue is an open source project, and it's backed by Redis. So that's our first system. Next, we needed to support webhooks. Webhooks, if you don't know, are essentially callbacks that fire to a customer's external systems to kick off things like CI after code is pushed. And to support that, we needed a queuing layer that could scale. And it had to scale across many hosts, and it had to support a highly parallel workload. We built that at the time with Kestrel. Finally, we got big enough to need a data warehouse. So that meant we needed to be able to ingest high-volume event streams. So for us, that was things like page views or fetches to Git repositories. So to support that, we introduced an analytics pipeline. And we built that with Kafka. So at this point, I hope you can see, there are multiple different systems. And they're all very similar, but they're not quite the same. And what I mean by that is that they all have different message delivery semantics. They have different transport protocols. They need many processes to do so. Each one of these processes has its own virtual machines, so I don't typically worry about performance until I need to. I think there's lots of times when programmers are patient. And that's because a key component of Hydro's success is going to be its ability to scale and its raw throughput. Next, and this doesn't require too much explanation, but is strong typing, so powerful type system. Basically, when you have a data system that's job is to shuffle from data from one area, certainly use systems like that at the periphery. But in the core of our data system, we didn't want to spend things come together to form a single sentiment. And that is that GitHub loves Ruby. And we truly do. But we also use, we don't just write Java, but we also use Java that others have written.
To update the code review and code management practices used for the JDK. Now, in the JDK, we like to update the JDK sources to use those new language features we come out with. We're not quite as diligent updating our tests, though. Perhaps you know that feeling with your own code bases. So Eric, could you help me update a test I wrote a few years ago?
Absolutely. So we have the test in front of us right here on GitHub. The source code is in my browser. And I'm actually going to go ahead and edit this file, Joe. I noticed a line that could really benefit from local variable type inference. So let me scroll down a little bit.
New JDK 10 feature.
And oh, there we go. So I'm going to go ahead and change this to use var instead to make the code a bit easier to read.
Sounds good.
So I'm actually going to go ahead and create a pull request for this. And the number you see me typing is just a made-up issue ID for demo purposes. And we're going to add a little body to make the code easier to read. And let's splash it up with an emoji. And go ahead and create that pull request. So we're going to click through and really create that pull request. And what you now will see happening is our bots kicking in and analyzing this pull request and providing feedback to the contributor. You can now see Duke greeting me. Welcome back, Eric. Duke knows I'm an experienced contributor, and I've done contributions before to OpenJDK. But we also have the JCheck. And here it seems I didn't do really as well. So let's click on the details. Oh, it seems like I managed to slip in a trailing white space there in my little patch. So let's click on that and see the details. OK, here we go. Yeah, I can see the trailing white space for sure. And it seems like Joe is already on top of things and has already suggested a change to remove the white space. That fix looks good, Joe.
Can't have that trailing white space.
For sure not. I'm going to go ahead and apply this commit.
Almost as bad as a tab.
So there we go. I just applied Joe's commit to my pull request. And JCheck will now rerun and recheck my pull request one more time. So let's go back to the conversation view and scroll down a little bit and see what's going on. So it seems like JCheck is still in progress. It is built using Java, JDK 11, and the GitHub Apps platform. And this is the part where I cross my fingers and hope my backend code works. So we're going to refresh that one more time, and JCheck is done, and it looks like it failed again. Let's see. Oh, I'm missing a reviewer. Every patch to OpenJDK must be reviewed. Fortunately, I happen to have an experienced OpenJDK reviewer
I can help you out with that.
next to me. Joe, would you mind reviewing my change?
Certainly.
Perfect. So now let's go back one final time. Scroll down a little bit. We see that JCheck is running again, analyzing everything, doing its work on the back end. And now all check marks are green, and the patch would have been ready to be integrated. So, Matthew, would you like us to tell us some more on how people can get involved and bring some feedback to Iskara?
I would. In fact, what's super interesting about this entire demonstration is that it essentially empowers any individual developer to be more potent, to have more contribution, more impact to this community through the automation that you gentlemen provided. So thank you very much for that. That was an impressive demo. And now that you've seen the platform, the investment, the usage, and the automation that make GitHub and OpenJDK a helpful pairing, even now in the investigative phase, I want you to think more importantly about the global community that contributes to this and many other important Java projects. And really ask, what can you do today to help strengthen that? Once again, I'd like to narrow your attention from the vast to the small, from 1.1 billion contributions to 31 million users to 4 million Java repos, but down to a simple number that's memorable: one next step. Think of posting one link to the project, making one helpful comment on the mailing list, jumping in and adding value to a discussion on the OpenJDK IRC channel, poking around and testing the OpenJDK mirror, giving one piece of constructive feedback to the Project Skara team. Because one is all it takes to build a great community of many, and that's you. Thank you very much.
All right, thank you, Matthew. Thank you, Rafer. Thank you, Joe and Eric. That was great to see. We're going to be looking forward to continuing improvements and certainly watching Skara with a lot of interest. So speaking of improving, it's amazing, really, to reflect on the amount of evolution which Java has gone through over the years. Each version has brought new capabilities and support for handling increasingly advanced challenges. So just as Java has grown, the ecosystem has grown with it. And this results in a virtuous circle that we all benefit from. A community this size brings a lot of possibilities, but it also brings some challenges, such as conflicting needs from different groups of users. Some people want more and faster innovation. Others just want the stability that they associate with minimal change. So to help us balance these sometimes conflicting goals, we have a set of principles which underlie the evolution of Java. Our development happens in OpenJDK. That's where we're working. And one of the great things with OpenJDK is you can witness yourself the design discussions. You can see the code changes as they happen. You can observe the evolution of ongoing projects that may result in the next features that come into Java. We're constantly talking with Java developers like yourselves to understand what your needs are. But we also talk to developers who have chosen other technologies because we want to understand the places where we can do better. But always, we're focused on the areas which help developers, whether they're deploying microservices or terabyte heaps. Last year, on this stage, we announced 3 commitments. And over the past year, we've delivered on all of those. We contributed the remaining closed-source features to OpenJDK. And what this means is that you can be comfortable using them. You can be comfortable collaborating on them. And this is our way of trying to make sure that Java is the strongest technology it can be. Now, in addition, Oracle started delivering binaries that are pure OpenJDK code, and we delivered it under a GPL license. That brings you unprecedented freedom of where and how you can use it. I spoke a little bit earlier about the tension between stability and innovation. Now, these two are not always at odds. Rather than be content with the disruptive and unpredictable major releases every 2 to 3 to 4 years, we said we would start delivering improvements in smaller, incremental pieces, right? More rapid and regular 6-month increments. This allows us to bring these improvements to developers much more quickly. Now, since JDK 9 was delivered just over a year ago, we've shipped the first of these 2 6-month releases. We shipped JDK 10 in March, and we shipped JDK 11 in September. Now, each of these were roughly the size of the minor releases that we had on 6-month increments for JDK 7 and JDK 8. The difference is we were able to deliver improvements and refinements in the Java language and in the APIs. And for those who want the peace of mind of having a version in production that has all the benefits of stability, security, and performance fixes, but without introducing new features, we designate specified releases as LTS, or long-term support releases, a concept we borrowed from the Linux community. And this is basically something that's planned to happen about every 3rd year, which it turns out is roughly the cadence that major releases were happening on previously. So, as always, you have a choice of where you want to go for long-term support. Now, at Oracle, we've tried to make that choice really, really easy for you by providing an affordable alternative and one that scales with your usage. This provides access both to LTS updates, but also a channel for reporting issues and receiving patches with at least 8 years of support for each version, so that you have a substantial overlap and allow you to choose when and how you want to migrate. With the release of JDK 11, we are so pleased to see the increasing involvement by a growing set of people throughout the ecosystem. In fact, JDK 11 has the most involvement from outside of Oracle that we've seen on any release of Java ever. And because this work is done in OpenJDK, you can learn about it. You can go and you can see who's done what, who's contributed, how much, in which areas, and decide areas where you may want to contribute in the future. OK, so in addition to working on the code, Oracle has continued its strong support around programs for Java. This lists just a few of the areas that we've invested in. Many of you are probably familiar with the Java Champions program. Many of the speakers here are Java Champions. You may be familiar with the Java user groups. If you're not, please check them out. These are wonderful resources and organizations that can help you learn and find out about what's happening in the Java world and in the ecosystem in general. OK, so in the past year, we've come a really long way. In fact, to quote James Governor, loosely quote James Governor from RedMonk, there's more that's happened in Java in the last year than in the last 10 years combined. And we've increased the pace of delivery while staying true to our principles and also offering you more and more choice. So to dive a little bit deeper into these changes and also give us a glimpse of what's happening in the future, I'm very, very pleased to welcome to the stage Mark Reinhold, the Chief Architect of the Java Platform.
Thank you, George. Hello, everyone, and welcome. I used to say welcome to Java 1, but I guess I shouldn't say that anymore. So as George mentioned, it's been a year of change for the Java platform. I'd like now to focus on 3 of the biggest changes, the likes of which we've never seen before. The first is that we took this massive monolithic platform that grew monotonically over time. It's this huge, huge thing, and we split it up into 26 standard modules. Second big change is we removed the Java EE and Corba modules and some other APIs. This left us with 19 standard modules. The third big change is we left behind our historically grand and majestic but slow-moving and, frankly, unpredictable release model in which we shipped a major release, modularizing the platform and removing some modules, some APIs, did break a few things. Many people have wondered, and understandably, whether the field Oracle has open-sourced all of the significant commercial features that were previously available only to paying customers, these including application class data sharing, Java Flight Recorder, Java Mission Control, and the Z garbage collector. Oracle builds and OpenJDK builds at this point are functionally interchangeable. This means that you can switch from one to the other as you please. It also means that all of this code is available under the GPL for anyone to build, test, publish, update, and support. So going forward, you'll continue to be able to get Java implementations in most any Linux distribution, whether derived from Red Hat, Debian, Gentoo, or even Arch. You'll also be able to get it from other providers. Now, as with any enormous change, there are lots of worries and some confusion, and this is all understandable. So I'd like now to address the top 5 misconceptions about the new Java release model. Number 1, every feature release will be as disruptive as past releases. No, that's not true. The rate of innovation hasn't changed. What's changed is the rate of innovation delivery. Innovation will continue at the pace it always went, but there will be more opportunities to deliver it. Number 2, non-LTS releases are experimental. It's just a fancy name for a beta. Why did you call it that? No. The only difference with an LTS release is that it has a longer support timeline. You can use a non-LTS release in production if you like, but know that you'll have to update it in 6 months or else find someone to support it, or else perhaps support it yourself. Number 3, to remove an old feature, it must be deprecated 3 years in advance, since some people will only use the LTS releases. False. To remove a deprecated feature requires a production-ready build that issues a suitable warning at either compile time or runtime, because a working build, after all, is the ultimate release note. Number 4, if you maintain an infrequently migrated system, then you could ignore the non-LTS releases. That would actually be a bad plan. If you test with each feature release, test your infrequently migrated system with each feature release, then you'll be ready to migrate that system to the next long-term support release. Number 5, there will never be more than 6 months of free updates for any non-LTS release, and there will be never more than 3 years of free updates for any LTS release. Not true. It all depends on what the non-Oracle contributors in the OpenJDK community decide to do. They already have a proven track record with JDK 6 and JDK 7, and they're already discussing how best to update JDK 8 and JDK 11 for the long haul. Now, it's important to keep in mind the distinction between updates and support. If you want guaranteed active support, rather than just updates with the latest security fixes, you're probably going to have to pay someone. You'll have many providers to choose from. When you choose a provider, you might want to consider those with the depth of knowledge that comes only from a long-term investment in the platform. To sum up, we're evolving the Java platform at a more rapid pace. We're doing this in order to keep up with competing platforms. We have broken a few things, and we will continue to do so, but in a careful, measured way in order to make Java a better fit for modern applications. Are these changes really all that scary? No, I don't think they are, for 3 reasons. First, we'll always give advance notice before removing anything. And we'll only do so when there's a very good reason, because we do not want to break existing code unnecessarily. Compatibility remains one of the core values of the Java platform. Second, it's true that Oracle will no longer provide free long-term JDK updates, but Java is still free. Free updates will be available from a variety of other providers. If you want active support, then you're going to have to pay someone or else do it yourself, but that's actually always been the case. So choose your provider wisely. Finally, we did break a few things, and it's true that migrating past Java 8 may require some work, but it might not be as hard as you think. All 3 of the major IDEs already support most of the new language features. Many popular tools, libraries, and frameworks already support JDK 9, if not JDK 11. You don't have to take my word for it. Just after Java 9 was released, I asked on Twitter, do you maintain a popular Java library, framework, or tool? If it works fine on JDK 9, then please reply with its name and version. That was a whole year ago. So shortly after JDK 11 was released, I asked, do you maintain a popular Java library, framework, or tool? If it works like heaven on JDK 11, then please reply with its name and version. Thanks to Sam Brannon of the JUnit team for that hashtag. I saw many, many responses. All 93 of these libraries, frameworks, and tools work just fine on JDK 9. In many cases, they worked without change. In some cases, the maintainers fixed them, and in many of those cases, it wasn't that hard to do the fixes. This list includes the usual build tools, Ant, Maven, and Gradle, test frameworks, JUnit, TestNG, popular libraries such as ByteBuddy, Jackson, Log4j, Hibernate, Juke, and Netty, and the entire Spring framework. 51 of these components work not just fine on JDK 9, but like heaven on JDK 11. Since the transition from 9 to 11 is much easier than the transition from 8 to 9, I expect that the rest of these will catch up in short order. My most important advice to you today, then, is this. If you're using Java 9 or later, upgrade to the latest versions of all your tools and dependencies, because everything changes and nothing stands still. So all of these changes, the modularization of the platform, the removal of some modules and APIs, and the shift to the new release cadence began with Java 9. Java 9, a moment of silence, the last final massive JDK release. There were 90 JEPs in JDK 9. It shipped 3 years and 6 months after Java 8, which shipped in 2014. That's 3 years and 6 months with, if I recall correctly, 2 major slips to the schedule. Java 10 shipped on time in March of 2018. It contained a mere 12 JEPs, but these aren't trivial JEPs. They even include a language feature, local variable type inference. Java 11 shipped just a few weeks ago. It contains 17 JEBs, 17 features. And of course, all of these releases contain many bug fixes and smaller enhancements not listed here. Java 12, in development right now, contains 4 JEBs so far. This will ship in March. You know, if some manager type asks me for the list of all the features that will be in Java 12 and JDK 12, I will say, ask me in December when the release is frozen. Right now, we just don't know. This is one of the real beauties of the Rapid Cadence release model. If you'd like to play with these features in JDK 12, you can find the bits at jdk.java.net/12. We love feedback. Feedback is really important. OK, at this point, let's take a closer look at some of the features in these recent releases and also try to peer into the future. What is it that drives Java forward? It's really 2 big goals. It always has been 2 big goals. One is developer productivity. Java is about helping developers build and maintain large and reliable programs. The other big goal is program performance. And this has many aspects, including startup time, latency, throughput, static and dynamic, storage use, and scalability from iPhones to Big Iron. We pursue these goals in the face of foreign functions and foreign data, and Valhalla, which is about value types and specialized. But, well, Java, just as everyone knows, it requires too much ceremony. It's a fairly being able to express more clearly what you mean. The boilerplate tends to take care of itself. Notice it's important. We're not just optimizing boilerplate. If we wanted to optimize boilerplate, we would find new Amber features. First, local variable type inference, the Lambda expression. Fortunately, that's not the case. The compiler infers the type. Look at another example of verbosity. Buffered reader equals new buffered reader, new file reader, a file. OK, yeah, you can do that, but now yours twice. Local variable type inference, you just type var. Some of the details are in JEP 286. Second feature of Amber, expression match, something like this. And since you're using regular expression operators, you need to type a backslash. But since the regular expression is encoded in a string, you need to remember to double the backslashes. And this is the W's are no longer doubly escaped, and they're enclosed in backticks in orange, and that's what delimits a raw string literal. The compiler treats this as a real and takes that as the value of the string. So this is pretty neat for a variety of uses. If you're on Windows and use backslashes, you can use raw string literals and type it in the usual way. And pluses and all of this other stuff, and there's a lot of clutter. With raw string literals, will include all of the white space in that code, and some of that white space is due to the indentation of the Java code itself. To help get rid of that, to make it easy to get rid of that unnecessary white space, we've added to what's, in this case, the start of the HTML element. Raw string literals are available in Java 12 as a preview feature. For the first time, we're doing preview features. These are features that are part of the specification. They're implemented, but they're not quite 12 early access right now. Another preview feature. It's a switch. You've got a numLetters variable. You've got cases. You assign numletters in each arm. And if what you get isn't a day of the week, then you throw an unexpected day, bugs to hide. You can forget a break. You can forget the default. You can get one of the cases wrong. You know, it's code that might not be that hard to write, nicely lined up. We use the same arrow syntax that we used in Lambda expressions to denote the throw an exception, because it's just not going to happen. Now, if you forgot a case, the compiler will complain, and you can fix that either by adding the missing case or by adding a default case. So switch expressions are also in JDK 12 early access as another preview feature. Another example, POJOs. We all know POJOs. Here's a classic POJO. It's a point, double X, double Y, constructor, accessors, and oh yeah, I forgot something, didn't I? Yeah, we need equals hashcode and ZooString and all of this boilerplatey stuff. IDEs can generate this, but that doesn't really help with reading, and that makes it easy to cut corners and introduce bugs. Another thing about POJOs, especially a POJO like this, is that the encapsulation it provides as a class is not actually necessary. What we need is a way to say that this class is just a transparent container for some data. Records do just that. They replace all that POJO code with just one line, because sometimes data is just data. You can customize records. You can override the hashcode method if you like. You can define additional methods. Here's a norm method for our point. You can customize the constructors to check invariance as points are constructed. What you can't do is add instance fields, because instance fields would break the very different definition of a record, which is that its data content is transparent. It's just a dumb container for data. So that's a no-go. If you need to add a field, then you just need to write your own class. OK, so that's records. As a final example, I'd like to look at pattern matching. Suppose we have an object. We know in our heart of hearts that it's an integer, it's a double, or it's a point. We can write this chain of if-then-elses. If ob instance of integer, cast it to an integer, produce the format string, so on and so forth for double and point, and at the end return s. Sure, that works. It's tedious, but it works. With pattern matching, we can avoid the casts. If ob instance of integer I there is a pattern made out of the type integer, and I, a variable that will be bound by the pattern. So within the scope of that if block, I is the integer value inside the object. You don't need to cast it yourself. So you can just say string format of I, and likewise for the double and the point. Now, as you might expect, and this is an aspect of many of the Amber features, is that they're designed to sort of all interleave with each other and leverage each other over time. Pattern matching works well with switch expressions. So you can use patterns in the case elements of a switch expression to deconstruct the thing that you've got and get the values out of it without having to cast and all of that other tedious stuff. OK, so that's been a look at Amber. Local variable type inference is in Java 10. Raw string literals and switch expressions are in preview in 12. Records and pattern matching are in development now. They're actually in the Amber repo. If you'd like to clone it and build it yourself, you can do that. Let's move on and take a look at Loom, which is about continuations and fibers for the Java platform. If we could please switch to demo 1. Ah, it is demo 1. Excellent. OK, continuations and fibers. Going to switch into demo mode now. Here I have a very recent build of the Project Loom primary repository. Built just a few days ago. Let me pop into JShell and let's take a look around. So Loom, as you might guess from its name, has something to do with threads. Threads have been around in Java from the very beginning. They're useful for many things. Let's just make a little example here. Here we've got a thread. We can start it. It'll run. It'll print hi. Oh, yeah, very good. Threads have a lot of baggage. There's a lot of stuff here that actually doesn't make a lot of sense in the modern world. Actually, and some of it didn't make sense when it was introduced. Threads have a thing called a context class loader, which was a bit of application state. Somehow, back in the day, it leaked into the Java platform. They've got thread groups, which are, frankly, mostly useless. They've got priorities, which mean almost nothing in most implementations. A Java thread corresponds to an operating system thread, and that means they're expensive to create, and it's expensive to switch context. It's expensive to switch control from one thread to another. This leads people down the path of having to use something like non-blocking I/O, the NIO APIs we introduced in Java 1.4, which you can use to build very fast and efficient services, but it's notoriously difficult to get non-blocking I/O right. You're basically doing all of your programming at the level of a state machine. As a result of this, many people just write normal straight-line code. They use threads, the threads block, and servers wind up being underutilized because they have to wait. So in Loom, we have fibers. A fiber is a lot like a thread. Let me show you. Get the right parens here. But a fiber is not associated with an operating system thread. Note it says here, no carrier thread. A fiber will be assigned to a thread by the runtime scheduler, which is in Java, not in the operating system, when you try to run it. So if I run f.schedule, that will submit it to the fiber scheduler. It'll run. It'll say hi, and I get back the fiber, which again has no carrier thread. It had a carrier thread for just the little moment it needed to run that tiny bit of code. Now, a fiber works much like a thread, but it's much simpler than a thread. These are the only methods in the fiber class, at least today in the prototype. There are some interesting methods here besides the usual ones. There's a wait. You can wait for a fiber to complete. You can cancel a fiber. You can check whether a fiber is canceled. And you can schedule a fiber. And all the rest is just inherited from object. Fibers also work well with completable futures. I can do something like completable, can I remember how to spell this? Ah, there we go. Completable future CF equals fiber.schedule. Here I'm using a static version of the schedule method, if I can spell. Now I've got a completable future. It's not completed, surprise, surprise. So let's make it complete, and we get the result back that we expect. So fibers are a lot like threads, but they're not threads. And in fact, fibers don't inherit from threads, and threads don't inherit from fibers. They do share a common superclass in the prototype called strands, but we're actually not sure we're going to stick with that. It's going to depend on getting more experience with the API. Fibers are designed to make it fairly easy to migrate an existing body of code that uses threads to use fibers instead. So let's take a look at an example. I'll drop into my favorite IDE, namely Emacs. So demo Loom, REST, applause, thank you. Source main, Java, Loom, sleep service. So I'm gonna make this little sleep service. There's just a REST service using JAX-RS and Jetty. It's pretty trivial. You invoke it. You invoke it through a REST call. You can pass it a parameter called milliseconds. It defaults to 100, and it just sleeps for 100 milliseconds. Simulating all this work that it would be doing if it were actually a thread that we're handling the connection. So let me just check something here. Okay, I'm going to make run this service in Jetty, but I'm going to use plain old threads, and let's see what kind of performance we get. Whoa. Okay, Mark, what did you call it? No, you're in the wrong directory. Okay, off we go. Does a bunch of stuff. I'm using the Vegeta or Vegeta, I'm not sure how to pronounce it, load tester doing a bunch of local HTTP connections. Warms up the server for 4 seconds and then runs the actual test for 8 seconds. And it gives us, in the end, a pretty graph. Here is the graph of the threads example. Ta-da! Well, that's pretty noisy, isn't it? That service is sleeping for 100 milliseconds. That's right down here at the bottom. But as you can see, many of these requests are taking a lot longer, up to 2020, over 2 seconds to do this trivial thing. That's because the whole thing is just, the operating system is bogged down with thousands and thousands of threads. It's working its little heart out, trying to handle them all, and it's just doing the best it can, but it's not good enough. All right. We made a fiberized version of Jetty, which I'll show you. Cool thing about Jetty is it's this lightweight server that you configure by writing Java code rather than a bunch of XML or something even more obscure. The important point is, when you start it, you can give it a thread pool of your choice. In the threads test, just handed it a normal thread pool. For the fibers test, we're going to hand it a thread pool that actually fakes it out. It doesn't use threads, but its execute method uses a fiber. So I'm going to make the fibers version run. That goes off and does its thing, 4 seconds of warm up and 8 seconds of test. This is live code. It is a prototype. Sometimes it doesn't work. Connection refused. Let's see. I have a hunch. hsrpid.log. OK. Yeah, a fatal error has been detected. OK. Let's try again. Prototype code. I mean, fibers are implemented deep in the Java virtual machine. There have been massive changes in the runtime compilers, in the JVM, to get all this going. But sometimes it's still a little flaky. Still just a prototype. OK, that actually looks better. Refresh this. And lo and behold, OK, here we go. So it's actually kind of hard to see the fibers data because the threads data is so large in magnitude. Let's zoom in a bit, shall we? The fibers version of the Jetty server starts out immediately responding to things in under 150 milliseconds, and it quickly, as things get optimized, sticks right around 100 milliseconds for the entire rest of the time. Well, the thread server, it just kept spiking and running into thread loads and thrashing the processor, thrashing the operating system. So they're a bit flaky, but they're really fast, even right now. All right, next let's take a look at Panama. Panama is about improving the connection between native code, and foreign data and Java. That interaction today, and that interaction for a couple of decades now, has been just really painful. Many people know the pain of JNI, the Java native interface. It's painful. It was actually intentionally designed to be slow, believe it or not. To use it, you have to write C code, compile it into a native library, a .so or a DLL, stick that in the right place, load it as you go. It's just a hassle. So Panama is meant to be a new native foreign bridge, or an isthmus connecting the continents. Get it? It consists of 3 main components, at least in the current prototype. There's a Java API that models C data types. There's an extraction tool that transforms C header files into Java interfaces that use the API. And then finally, there's a runtime binding mechanism that synthesizes implementations of those interfaces as they're needed. So let's take a look at the demo here. Make sure I've got the right Java. Yep, Panama, built just a couple of days ago. So canonical test of any foreign function interface is get PID. Right? Really simple, native function, can return you the process ID. So let's write some code that does that. Well, first, we run a tool called JExtract. JExtract is the extraction tool. We tell it, give it an include file, or many that we might be interested in. In this case, we're interested in unistandard.h. And yeah, let me just be paranoid here. Oh, that's entertaining. Okay. You're not seeing this. That's a bit. Pay no attention to the man behind the curtain. I need lib do. Ah, okay, that worked. What have we got? Oh, we've got a whole bunch of classes in this classes directory. The important one is unistandard.class near the top there. Let me show you what's in it. A bunch of familiar things. All these familiar faces. We're used to seeing them in C as part of the Unix API. Here they've been translated into Java. We can invoke lseek, we can close, read, write, pread, all this other stuff. And somewhere here is getPID, which is the one we're after. Public abstract int getPID. Okay. Don't clap yet. I haven't shown you anything that actually works. All right. Let's go back into Emacs here. What do I call it? Getpid.java. Okay. We import a couple of the Panama prototype packages, the basic foreign function interface. The foreign memory package contains the Java model of the C memory, the Java API for the C memory model, and we need Java lang invoke just to get things going. In our main method, we invoke this libraries.bind method. Libraries is a class in the foreign function interface. We pass it the class object corresponding to that unistandard thing that we just looked at, the one that was made by the extraction tool. And then we've got, a unistandard object that can print the process ID. And just for amusement, we'll double check that that really is the process ID, or at least that it matches the one that Java thinks it is. All right. So I can Java C, class, path, classes, getPID. Good. And the process ID was 32,135. Okay, so that's invoking a native method using this extracted API and getting a value out of the C library. We can also manipulate and look at foreign data. So let me show you an example of that. Let's go back into Emacs. We'll look at another manual page here for clock get time. So clock get time gets you the current time. The interesting thing for the purpose of this example is that it works on a time spec. You pass it in a little C struct that contains two fields, the seconds and the nanoseconds. So once again, we will run a JExtract. Because it's a prototype, it's a little involved as to what it needs to do. So I will use a little makefile. And it goes off and crunches a bunch of stuff. And this time it put those things in a package. And there are many interesting things in here. The most interesting ones are 3 interfaces that were created for struct time spec. And that one with the $sign in it, this is a prototype. It'll get cleaner over time. That one with the $sign in it is the one we're after. It represents this structure. Classes, demos, struct, time, spec. As you can see, it's got methods for the seconds field and for the nanoseconds field. You can both get and set those things. So, go back to the code. Here's the clock get time code. We import the similar stuff. In this case, we open a new native scope. So this is using the C memory model API, opening a native scope for some more native data. We allocate an instance of the timespec class. So we allocate that little 2-element timespec struct, and then we get the time, and then we print it out. Oh. That's weird. Ta-da! We got the timeout. But we did this by passing in a C struct that we allocated in Java code. The C library put the data in and gave it back to us. All right, so it's a little rough, but it is a prototype, but it is working. There's quite a ways to go here, and there's more to come. OK, so that's Panama. Last thing I'd like to look at is Valhalla. Valhalla is about value types and specialized generics. The motivation for Valhalla is the fact that today's processors are vastly different than they were in 1995. Here's a die photo of the processor in this very laptop, an Intel Skylake chip. The biggest thing that's changed, well, many things have changed. We have multiple cores and so forth. But another huge thing that's changed is that the cost of a cache miss has increased by a factor of 200, or in some cases even 1,000. Processors got faster, but the speed of light didn't. Oops. Chasing all of the pointers that are inherent in Java data structures is therefore costly. And there's so many pointers because every Java object has identity. Every Java object has the possibility of having a synchronization monitor attached to it. Every Java object has state. And this is especially painful for things like big data and machine learning applications. The missing abstraction in this case is value types. That's the ability to declare pure data aggregators without identity. Suppose we have, remember our point class from a previous example, suppose we have an array of points. This is how it's represented today. Every point is a self-standing object. And there are all these pointers going around. And if you've got a gazillion of these, then just traversing this array is easily going to blow out your processor cache. What we want is the ability to declare pure data aggregators, but still consider them to be defined by Java classes. This enables allocation in registers. It enables flattening of data structures. And in this case, if points were a value class, the representation would look like this. But you would still program it as if it looked like the previous thing. As John Rose likes to say, the motto of Valhalla is, it codes like a class, but it works like an int. Pretty cool. So I'd like to show a little example here. Just put it back here. Here's my Valhalla build. Now let me just do one thing. To reset, you didn't see that. All right. So I've got some code here. Rather than operating on points, this example works on complex numbers. So here's a complex, the obvious complex number class has a real part, an imaginary part, has a constructor, it has the accessors. If we had records, this would be easier, wouldn't it? Yes, it would. But we don't, at least not in this build. It has an add method, and it has a multiply method. Pretty obvious stuff. What we're going to do in this example is multiply two matrices of these complex numbers. So to do this, So here's the basic algorithm. Hopefully you all learned this deep in the past, and I had to go look it up again because I forgot the exact definition. Matrix multiplication, you've got two matrices. You do the pointwise dot product of the rows and the columns, and you get the results out. Nested for loops, standard algorithm is cubic. There are really optimized ones that are much more complicated to get a little bit faster. OK, so we're going to run this using just normal boxed complexes, the way you would get by default. I'm going to use Alexei Shipalev's very fine Java micro benchmark harness. That's what all these annotations are for. If you're ever if you ever think you need to do micro benchmarks in Java, I highly suggest you check out Alexei's framework. And let's run this. And let's hope for the best. It's all bundled up in a Makefile. If we go run Maven, oh good, it didn't need to download things. I'm cheating a little bit and only doing one, not doing as much testing as Alexei would recommend, but that's in the interest of time. So you can see it's doing these matrix multiplies, and it's taking almost 4 seconds for each one. Around 3,700 milliseconds for each one, even in warm-up, and it's not going to get a whole lot better. As you can see, the GC allocation rate here is, for each multiply, is almost 4 gigabytes. And that's because every time a new point is computed, well, it has to go allocate a new point, and so the garbage collector is working very hard to allocate memory and collect memory and do all of the usual stuff. So we'll get some stats out at the end here. Let's take a look at them in the log file. So remember, the numbers below are just data. Thank you, Alexei. So key numbers here. If you want to remember these, whoops. Each operation took around, it averaged out to 3,600 milliseconds. Another key number is the instructions per cycle. I already pointed out the GC rate. Here, instructions per cycle. The Skylake processor in this laptop is capable of retiring 4 instructions in every cycle. In this multiply, it's able to retire only about 1 in every cycle. And that's a strong indication that the processor is sitting around just waiting for memory accesses to happen. OK, I'm going to make one change to the complex class. I'm going to say public value class complex. Then I'm going to run it again. OK, good. Maven still didn't need to download anything. OK, warm-up iteration. We see even in the warm-up, it's a lot faster. 290 milliseconds per operation. Get through the first iteration here, look at the GC counts. It's allocating about 4 megabytes per operation. And that's really only for the result matrix. It's not having to allocate a new point object every time a new point is computed. All right, let's go look at this again. OK, here are the numbers on the top will be for the boxed complexes. On the bottom, we will look. Oops, I didn't do that right. OK, let's just look at them here. So overall score, around 296 milliseconds on average, as opposed to 3,700, whatever it was. The GC rate we already looked at, a mere about 4 megabytes per operation. And the instructions per cycle, not 1, but 2.685. So almost 3 instructions per cycle. The processor is being kept a lot more busy. It is not spending so much time having to wait for the memory pipeline to deliver complex numbers to it. All right. So that is Valhalla. This concludes our brief look at some of the key projects that we're working on in the OpenJDK community. It concludes our brief glimpse into the future, things that we're actively working on to move Java forward. Java won't only move forward, but it'll move forward now at this faster pace with their new release every 6 months so that we can deliver these features coming out of the research and development pipeline in an even more timely fashion. And we can all move forward faster. Thank you very much.